So we started talking about standard deviation and the bell curve and stuff, but now we got to talk about this. Inequalities. Solving inequalities. And just to clarify, here is your simplest inequality. 2a is greater than 8. Everybody solve that. You treat them just like equations. Did you find yourself dividing by 2 on both sides? A is greater than 4. Raise your hand if you had gray is greater than 4. Okay, good. So, do you get that that answer looks like this? Here's 4. Here's circling 4. It's bigger than 4. Does it actually include 4? No, because 4 itself, when you put it here, that would make it equal 8. And we don't want that. We want bigger than 8. Okay, so it's an empty circle. What if I wanted that circle to be filled in? I would say or equal to, and that problem's different, and then I'd fill it in. Last thought about that is this answer could be written as 4 to infinity. If I want it to be equal to 4, or equal to sign, then I would use a bracket. If it was an empty spot, it would be a parenthesis. Okay, so there's your just quick reminder of how inequalities look. So let's take a look at this. This is like some polynomial, and they've graphed it. So this is a function. If I said, where is this function bigger than 0? That's like y values, like the height of the points, has to be bigger than 0. That's where 0 is. Do you get that it's bigger than 0 all that time? But wait, right, that second it touches 0, so that second it's equal to 0. And then it starts being above 0 again. So my answers on this one would have been between that spot and that spot, which was between -3 and 2. This thing was above 0 in that little interval. Between -3, right there, and 2, which is right there, it was above 0. And then, again, after 2, it worked. From 2 to infinity, it was above 0. That's where the function's above 0. That's a graphical way to think of it. This one, you don't want to try to graph this thing. It'd be really, really, really hard to graph. But my favorite saying still applies. Dominic, you know what I'm talking about? Yes. Please do, everybody. If we get this thing factored out, then we will know the key spots. That's what it's all about today, is the key spots. And I'm going to focus only on the x-axis. I'm not even going to draw the y-axis that goes up and down. I only care about the x-axis. And what are the key spots that are on that x-axis? It's kind of like that other graph we had a second ago, where it was like, ba-doop, ba-doop, ba-doop. The key spots, right there and right there. It's where it hits the x-axis. All right, so got it factored. You see why I had to have you get factoring down? I mean, we just keep doing it day after day after day. If you don't have factor, you couldn't even start this problem. So then I know it's a plus and a minus. I think it's smart to do the signs as your second step. And then I know that this 6 has to either be a 5 and a 1 or a 2 and a 3. And I'm pretty sure, 6 and a 1 or a 2 and a 3. And I'm pretty sure it's 6 and 1 like that. Anybody verify that? Okay, good. If you tried the 2 and the 3, I encourage you to multiply the outside and the inside. I'm pretty sure it doesn't make -5. Okay, so there. Now, what are the key spots? 3, -1, and 6. The things that make it equal 0. 6, -1, and 3. So everybody make a number line, just like I did, and put these in order from small to big. -1's the smallest, 3 is the medium, 6 is the biggest. And circle them. Now we just have to shade, and that's it. That's how you do these problems. You find the key spots, and then you figure out where it works by shading. We had a test on this. It's called testing intervals. And I did go on the record as saying kids are bad at testing intervals. A lot of kids get this part wrong, like trying to figure out where to shade. It's not super easy. Sir? Okay, that's a good question. I was going to ask that next, so why don't you tell me, do you think we should shade in these circles? Yes, because it says or equal to. When I stick 3 in, it will make this whole equation equal 0, and that's what it wants. Equal to is what it wants. So since it's an or equal to, all 3 of these spots are zeros. You should fill them all in. Now I just got to figure out where else to fill in. Like, it might work in this interval, but I don't know until I try. So what you do is you pick a number between 3 and 6. Addie, pick a number between 3 and 6. 5. All right, everybody, we're going to stick 5 into this equation. Just right above the x's, put a 5. And all we have to tell is if it's bigger than, we want less than or equal to 0. Remember, I don't care about the exact answer. I care, does it come out bigger than or less than 0? And I want the ones that are less than 0. What's 5 minus 3? Come on, help me out. 2. And then what's 5 plus 1? So it's 2 times 6 times 5 minus 6? Negative 1, and that's key. Do you get that just makes my answer negative? It doesn't even matter that it's negative 12. If it's negative, it's less than 0. That's what I want, is less than zeros, right? So I just checked the number 5, and I got negative 12, which worked. It was less than 0. So then I shade in there. Am I done? Well, I can't just say I'm done. I got to test all the other spots. And that's why kids struggle on this, is because they oftentimes will get one of them right, and all it takes is mess up one. Now you got to check 7. Then you got to check, why don't we check 0 for this interval, because 0 is an easy number to check. And then we have to check negative 2. Stick those in and try to figure out where it is less than 0 and where it's not. So again, right now you're testing 7, and then test 0, and then test negative 2. Eight times 4 times 1, it doesn't even matter what this number is. It's positive, and therefore it is not less than 0. When I stuck in 7, it did not come out less than 0, so that did not work. Crossing it off. When I stuck in 7, I got 32, and 32 is not less than or equal to 0. That's what you got to keep coming back to, is this sign. Did what I get come out to be less than or equal to 0? And 32 is not less than or equal to 0, so I crossed it off. Dominic, would you please walk me through putting in 0?
So 0 minus 3 is -3.
Okay, hold on one second. I got to catch up. So I'm putting in... iPad's going slow today for some reason. Okay, there. Put in 0 and I get negative 3, then what? And then?
0 minus 6 is -6.
Excellent. And now I don't even care what the number is. I got 2 negatives. That comes out positive. So is that less than 0? No. It did not work. Because it came out to a positive number, positive numbers don't satisfy less than 0. That number is not less than 0. Okay. And then last but not least is negative 2. Trent, I'm going to stick negative 2 in. What does that first parenthesis come up to if I put in negative 2 for the x? Negative 5 parentheses. What's the next one?
-1.
Yep, what's the next one?
-1.
And if I have 3 negatives, negative. Are negatives less than 0? Yes, so it worked. I shade in there too. And there's my answer. Now, I want to show you something, and some people, you're going to understand this, and some aren't, and it's okay. If I graphed the original function, this is what it would look like. That blue swoopy line, I wanted to know when it was less than 0. Do you get it was less than 0 in there? And the blue swoopy line was less than 0 in there? And that's why it worked in those zones. All right, you don't have to understand that part. What you have to understand is how to figure out, how to factor it basically, put those numbers on the number line, and test the intervals. Right, let's go to the next one. Now, this has got like a million problems on it. We're not obviously doing all of them. All right, we've got the same problem copied a million times. Why? Because they're just giving you a chance to test intervals on like writing the number above it so you don't have to erase it all the time. So what are the key numbers? Let's make a number line. And there appears to be 1, 2, 3 key spots. But wait, one of them isn't real. Anna, can you tell me, what do I get for that one? What do I get for that one? Can you make that part equal 0? Is there anything you could stick in that would make that equal 0? That's an excellent question. You would want to factor it. I agree, except you can't. If it was x squared minus 1, it would totally factor. But that, it doesn't factor. And there's no way to make it equal 0. Let's ponder that for just a second. What number could you put in here that would make this all equal 0? You might think, well, let's put in negative 1. But then it squares and it becomes positive 1. There's no way to make it equal 0. So we can just ignore that one. There's no way to make that equal 0. That means it's not an x-intercept. And remember, these are graphs. And this would not be touching. That spot right there wouldn't be touching at all. It only touches at this spot and this spot. Okay, so now we're going to try 3 and 4 themselves. Notice this is equal to 0. But down here, they got all these different signs going on. Which is it? All right, well, in my opinion, I would just like to test and see, when is this thing bigger than 0? Ignore all the other ones for a second. We're going to try to figure out, when is this thing bigger than 0? We're going to put it on our number line. Well, how about negative 3 itself? If I put in negative 3, it's going to make this whole thing equal 0. Is 0 bigger than 0? No. So I'm going to leave it empty. How about 4 itself? Well, that's also going to make it equal 0. So that also has to stay empty. Now we're going to test one number in each interval. George, I've chosen 5 for you. Would you please tell me, when I put 5 above each x, what do I get? So what's this part? What's this part? Nice. And what's this last part? Now remember, I don't care what 8 times 26 is. I care if it came out positive or negative. What did it come out? Are positives bigger than 0? Yes, so it worked. So I just checked the number 5, which was right here, and it worked. Shaded in right like that. All right, Ethan T. What's a number between -3 and 4 and is really easy to work with?
0.
Agreed. We're going to put 0 in. So I'm going to put 0 in for each x. Please walk me through it. If I put a 0 here, here, and here, what do I get for this one?
3,
What do I get for this one?
1,
What do I get for this one?
16.
Oh, you squared it. Awesome. I forgot to square it last time, and it didn't matter because it was positive. So positive 16. Oh, wait a minute. That might have messed up the last one. I forgot to square it, and you caught that, Ethan. Nice job. I didn't even see the squared. This one might not work. I'm going to double check this one. I'm going to double check 5 in a second here. Rats. I may want to re-record this in the next hour because that's a big oops. Okay, so we're going to finish off. We're testing 0 right now. We've stuck it in these 3 spots, and all of them came out positive. And are positive numbers bigger than 0? Yes, so it works. It works here. I bet it doesn't actually work in the other one. I'm going to retest it now that I noticed that that's squared. I'm going to go back over here and test 5 again. It was my mistake, so I'm going to have to, I mean, there was somebody else helping me, but I should have caught it. There's a 5 going in. Double checking 5. This one was 8. This would be 26. And this would be 5 minus 4 is 1. And 1 squared is still 1. Okay, it didn't come out negative, so it's okay. 1 squared is 1. I just forgot to square it. In this case, I got lucky. It didn't matter. All right, so that was positive, so it does work. Does it work everywhere? I would bet it's not going to work here, but I'm going to find out. I'm going to put in -4. Sophia, your chance to help me out. If I put in -4 for all my x's, -4, -4, -4. What do I get here? Good. What do I get here? Nice. What do I get here? Careful with the squared. You are correct. Notice there is a negative there. So that means this comes out negative. I don't even care. It's some big number. I'm not sure what, but it doesn't matter because it's negative. Are negatives bigger than 0? No. Negatives are not bigger than 0. That did not work out there. So my answer looks like this. I know it looks kind of messy. If I wanted to clean it up, I would say it worked between 3 and 4. Union 4 to infinity. Do you have to write that? Not unless on the test they say interval notation, because that's what that is. I like number lines. I personally am fine with you leaving it as a number line. But if you want to summarize it, it works between -3, it's a negative, between -3 and 4, and between 4 and infinity. Doesn't work at 4 because it was just a greater than sign. All right. I hope you're starting to get the idea. Let's move to this next page. This one seems way harder for some reason. Rissy, can you tell me how we're supposed to start it? Yes, you are factoring. X comes out. Claire, after I take an X out of everything, what do I have left? Nice. Claire, do you think you can handle factoring it next level? One step at a time. What goes here and here? Yep. Next thing is the signs. Can you tell if it should be minus, minus, plus, minus, plus, plus? Plus and a minus, because this number is negative. It must be a plus and a minus. And then last, how do you make a 15? Probably a 5 and a 3. Do you feel like we should make the 5 the positive or the negative?
Yeah, it would be +5 and -10.
You are correct. Nice job. Cool. Now, draw a number line, everybody. And put the 3 important numbers. A lot of people see these 2, but they like don't even see the one in front. Addie, do you know what I'm talking about? What's the other number?
0.
Yes, that's a 0. This is -5. And this one's 3. And then you put them in order from small to big. -5 can be here. 0 can be here, and 3 can be here. They have to be in order like a normal number line. And now, how about those numbers themselves? Ethan T, tell me, does 3 and 0 and -5 like work?
Oh, yeah, they're shaded in.
Yes, they're shaded in. Because why?
Equal, or greater than or equal to.
Yep, it's got an or equal to symbol, so you are correct. Fill us in, fill us in, fill us in. All right. Next up, Mason. Pick an interval and tell me what we should test.
1.
1 goes right in there, and we will test a 1. I'm going to put a 1 here, a 1 here, and a 1 here. Would you please tell me what I get?
You get 1,
Yep,
and then 6.
yep,
And -2.
perfect. And will that come out less than or equal to 0?
Less than.
It does come out less than, so it worked. So I shade it in. If you don't get that last part, it's because it came out negative, and negatives are less than 0. Now I know there's a classic problem. Some kids don't know whether that's a less than or a greater than. Does it kind of look like an L? Does it kind of look like an L? Yes, so that's a less than sign. So is this answer that we got, this negative number, less than 0? Yeah, negatives are less than 0. Okay. Claire, can you test another interval for me, like something we haven't tested?
-6.
Okay, -6 is way out here, and I'm going to stick a -6 in here, here, and here. And what do we get for the first parenthesis?
-1. Well, it would be -6.
Okay, -6 here, and then a -1, I agree, and then?
-9.
Yes. There's 3 negatives. I don't even care about the 9 times 6 is 54. All I care is there's negative times negative times negative, and that comes out negative. And now I have to decide, did it work? Tully, it came out negative. Did it work?
Yeah.
Yeah, because it's less than 0. So I tested this and it worked. I'm shading it in. I would bet you money that it doesn't work in there. Everybody test a number of your choosing, something between 0 and -5. And I bet it doesn't work. I'll tell you in a second why I knew that. And I might be wrong. Okay, I actually might be wrong. Definitely should test it. My gut says that it won't work, but I could be wrong. I am testing -1 because I feel like it's the easiest thing I could test. I got 2 negatives in here, so that comes out positive. Are positives less than 0? No, they're not. It didn't work. I thought it wouldn't work, but then I realized there was a way to draw the graph. See, I'm thinking about the graph and how the graph is supposed to be less than 0. And I was thinking, how could you have a graph like this and have it work? But there was actually a way. There was a way to graph that and have it stay below 0 the whole time. And here it is, just in case you care. It could have done that. that weird little green dipsy-do, and then it could have theoretically worked. And again, my theory is it's not going to work out here, but everybody test like 4. This is the tricky part. I'm telling you, I've seen a lot of tests on this, and it's the testing intervals. A ton of you are going to shade the wrong spots. You're going to be like testing 4, and you'll think it works, but it really doesn't. This is all about being careful, and math rewards careful people. That one, they're all positive, so it comes out positive. Happens to be 36. Don't really care as long as it's positive. Are positives less than 0? Nope. Cross it off. Okay. I know that got a little boring, but it's just kind of tedious. I don't feel like this test is going to be that hard, but it's definitely like going to reward the careful kids. You're going to have to really carefully test those intervals. Okay, I don't feel like I'm going to be teaching you anymore if we keep on going like this. So let me just sum it up. Do you get if you can factor it, you should, and sometimes you can't factor it? Do you remember the deal where if it's negative in there, you could factor this, but when it's positive, you can't? I mean, go ahead and try, but it'll waste your time. You can't factor that. All right, so don't bother factoring that. But can we factor the next one? Nope, the next one you can't factor either. There's nothing to factor there. So I guess you try to factor stuff, so if you can, you should. Then the next step is you put a number line and you figure out what makes each part 0. There's no way to make that 0. Try all you want to stick in any number you want and you won't be able to make it 0. But this one you can make it 0. I like to write it this way. 3 minus 2x equals 0. Three over 2. That's my only spot on my number line. Do I fill in that spot, Brady? Does it actually work at this spot? No, it makes it equal 0, and 0 isn't bigger than 0, so we leave it empty. Do not fill it in. Now, what's bigger than 3 over 2? That's like 2 is. This is like 1.5. So I'm going to stick 2 in. 2 goes here. 2 goes here. 2 squared is 4. 4 plus 9 is 13. And 3 minus 4, which makes -1, but it gets squared, becomes +1. That's a positive number. Are positive numbers bigger than 0? Yes, they are. So it works out there. And then I'd have to test something smaller, like 0. I'm going to put in a 0 here and here. And I'd get 9 times 3 squared is 9, and that's positive again. And are positives bigger than 0? Yes, they are. So I'd shade like that. There we go. And you can leave your answer as a number line. There's the process. These aren't as nearly as easy as yesterday. Yesterday, so much easier. All right, let's get to the worksheet. Everybody find the worksheet that is posted for today. I will cut a couple out to keep your life reasonable. But if you keep doing your homework, you will do so much better on this class. Sometimes you need a little reminder of why you should care about your GPA. Number one, at the end, when you're looking at colleges, which a lot of you will, if you don't have a high enough GPA, you just can't get into the college you want. Number two, it can be scholarships. There can be a kid who has a 3.4 and a kid who has a 3.5. And the 3.5 is kind of magical for a lot of colleges. If you have a 3.5 GPA, all of a sudden you get scholarships that the other kid doesn't. And then your college is just simply cheaper by thousands of dollars. Thousands. Like way more than you could earn in a summer. Just because you tried a little harder in high school. So there's reasons. And you'll probably remember your GPA for the rest of your life. You really will. And I'm not saying you should have a 4.2 like some people have. But if you didn't try hard, you'll never be like proud of that. All right. So I would say if I had a choice between being in a bunch of activities and having a little lower GPA, I'd probably pick that one. I'm not saying you should have GPA over everything, but when there's moments like this where we have a assignment and you should just make yourself do a little bit at home, it'll make a difference in the long run. You pulled it up. Would you read me problem number 1, please, sir?
X plus 1 times x minus 3 squared is less than 0.
All right, good. So first off, I'm making a number line, just right out the gate.
Should be bigger than 0.
Oh, is it greater than 0?
Or greater than 0.
Okay, that's an important one. There we go. Okay, now I'm gonna put my 2 important numbers on here. Claire, what's one of my 2 important numbers?
-1.
You are correct. And the other one?
3.
Correct. Now I'm gonna circle them. Should I fill those in, George? No, because it does not say or equal to. These will make it 0. These are called the zeros. And if you make it 0, you're not satisfying the equation. All right, now I got to test a number like 4. Rissy, if I put in a 4 here and here, tell me what I get. 5 and don't forget to square it, and it's still 1. And so 5 times 1 is 5. Is 5 bigger than 0? Yeah, so it worked. Now let's look at the directions, because if it says must answer in interval notation, we need to know that. Dominic, can you clarify, does it say we have to answer in intervals in the directions? It does not. Then you can leave your answer as this number line. That's it. I'm not done yet. I have to test here, which is 0, and I have to test here, which is -2. Claire Dance, if I put in 0, you're going to be in charge on this one. I put a 0 here and here. What do I get? And? You caught it. -3 gets squared, becomes +9. All right, good. Do you get that that's positive? So Claire, does it work? Yes, because it says greater than 0 and positives are greater than 0. We tested 0 and it worked. And last but not least, Trent, test -2 for me. I'll put it here and here, and you tell me what we get. What do we get in the first one?
-1.
Correct. On the second one?
-5.
Squared,
Squared is
25. The grand total come out positive or negative? Are negatives greater than 0? No. Doesn't work out there. There's your answer. And again, if the test said must answer in interval notation, you'd write this. From -1 to 3, union, always put a union between the two things, 3 to infinity. That's how it, if they made you do it, that's all you have to do is sum it up with one of these. Okay, cool. Now let me look at the worksheet and see which ones to skip. We'll do number 2 so you don't have to waste time waiting for me. Do number 2. That is an ungodly number of problems. Holy crap! That's insanity. All right. All right. I like to do this every now and then because I think it's good for you. We're going to do the prime numbers. So I know we already did number 1 and we're doing number 2. 2 is a prime. What are their other primes? This is an ACT question. What are primes? Well, what's the next prime after 2? 3. Is 4 a prime number? No, it's not. So you can cross off 4. What's the next prime number? 5. What the primes are is they're things that only have 2 factors, 1 and itself. So like 6 has too many factors, so it's out. 7's prime. How about 8? Nope, it's got too many factors. How about 9? Does 9 have some factors? Yep, so that's out. So we're doing the primes only. Keep going like that. 10, it's got factors, so it's out. I think you get the idea. We're crossing off lots of them this way. So do 2, 3, 5, 7, etc. If you can't figure out what prime numbers are, Google it if you have to, or come up and ask me. All right, and that's all I got for you for today.